Okay, this is just a follow-up video to adding geometric vectors. I just wanted to talk about a tension problem. There's been some on the homework questions, and a couple people have asked me about it, but not too many. So it could definitely appear on the test tomorrow. So just going to go over this basically, but I'm not going to do all the calculations. I'm just going to show you how to set it up. So let's just say a typical tension question could be, maybe you're hanging something from the ceiling, some kind of mass. And it's, okay, so let's just say you have some kind of weight here. And let's just pretend that that weight is like, I don't know, just 196 newtons. So there's this mass, and it's connected by 2 ropes, say, to this mass. And I would tell you the angles that those ropes are at. So let's just say they're at like a 60-degree angle and a 45-degree angle. And what's happening is the tension of the rope is pulling up, and then the mass is pulling down like that. So this box right here, this sign, is not moving. So we're trying to figure out, like, the forces acting upon it must be kind of like canceling each other out since the box isn't moving at all. So what we're trying to figure out here is we're trying to figure out the 2 tensions in the rope. So we're trying to figure out these 2 tensions. We'll call it the vector T1 and T2 for tension. And we want to know what the tension in each rope is. So we already know what this vector is. It's 196 newtons downward. And now we want to know, hey, what's the force or what's the tension in these 2 ropes? That's going to make this box not move at all. So there's like 2 ways you can do this. I'll just show you basically how to set them up. So you can do this using cosine law or sine law. I guess sine law would work. So where you are going to kind of like add up your vectors together. So like the 2 tensions should add up to the force that's pulling downwards. So like, for example, you could set up, okay, T1 is going to look like this. Oops, that's a TI. So there's vector T1, and it's at an angle of 60 degrees. So down here it would be like 60 would be here. So, oh, this is like a horrible drawing. Okay, one sec. Let me just make it look a little bit more accurate. Ugh, okay, I can't draw lines. Okay, so let's say this is at an angle of 60 degrees. So that's our tension 1, and then the other one's at an angle of 45. That's the second one. And then our resultant vector is going straight down, which mine kind of is. And that, we know that vector is just it's just going to be the addition of these 2 vectors. And we know it's already going to equal 196 newtons. So you know what? Setting it up this way is not too horrible. Because we know this angle right here, because this angle would be 60, and since this red line is like up and down, this angle here would be 30. This is like these are right angle triangles, so this angle here would be 45. So you know a lot of information from this triangle. So solving for these 2 missing sides, it's actually pretty easy. You could just use the sine law to find the missing sides. And yeah, I'm not gonna do this question, but I'll tell you the answers in case you want to try it. So T1 is gonna equal 143.5 newtons, and T2 is going to equal 101.5 newtons. So So those are going to be your answers using, you can just use the sine law to solve it this way. Or another method to do this is using components again. So same question, but you could break it into components. So kind of like leaving it as the same setup. So here you have one tension, the first one, and we know this angle is 60 degrees. And then the other tension, we know that angle is 45 degrees. So you could break it up into components. And you know there's a downward force of 196 newtons. So for this situation, we know that, so this is T2. Again, I'm not going to solve this, but we know that these components, the x components, these vectors here, they must be equal to each other. So we know we could say, since we can calculate this tension here to be T1, oops, I keep putting that. Okay, the magnitude of T1 cos 60 has to equal the magnitude of T2 cos 45. So these have to be equal, and if they're not equal, then the sign would be like pulled left or right, but it's not moving. So that means there must be an equal amount of force pulling it left and right. So we can say this. So here's like one equation we could set up. And T1 cos 60 just represents this line, and T2 cos 45 just represents that line. They're just the x components. And then another equation that we could create, it's like a little bit more confusing, but well, we know the vertical components have to add up to equal 0, so we know that this force here pulling up and this one, if we add those together, they should equal our 196. So remember how we do our vertical ones? We say, okay, magnitude of T1 sine 60 plus the magnitude of T2 sine 45 should be equal to 196. So what we've done is we've created two equations with two unknowns. So you can use like methods you've learned to solve that. So like for example, you could rearrange equation 1 so that we isolate T1 and we say T1 is actually equal to T2 cos 45 over cos 60. So that's what T1 equals, and I could actually figure out cos 45 divided by cos 60 if I want to, but I don't feel like it. So now I've got an expression for T1. So then I could actually take this part in the bubble and sub it in for T1. It's substitution. We learned it in grade 10. It's like really helpful. So for T1, and then it's getting multiplied by sine 60 plus T2 sine 45 equals 196. And I know it looks crazy, but like once you do the numbers, like do cos 45 divided by cos 60 times 60, you get like some number T2 plus some number T2 equals 196. Collect your like terms, divide, isolate it, and you should get the same answers as above. Okay, so that's how to solve a tension problem.